And welcoming to the stage, Erik Bosman.
Thank you. Yeah, I'm Erik. For my day job, I'm a postdoctoral researcher at computer security, the FUSEC group at VU. But this talk is not about that. It's about my hobby. For more than 10 years now, I've been making mostly LED art. So I started with one, then I made another one, then I made another one, another one. This one is a bit an odd one out. Made another one, another one, another one. So why? So these I didn't make these. These were found and dated to the Roman era, and nobody knows why what they're for. So, and there are lots of theories. So, I make these geometric shapes because I like puzzles, and nothing is more fun than to think of a puzzle and then solving it yourself. So these are and these shapes combine geometric puzzles, logistical puzzles, coding challenges. So lots of things I'm enjoying. I'd like to learn something new. So they're all spheres. They're all all have LEDs, but each new sphere has a new challenge for me in it. And I like hacking projects where I need to plan stuff, so I can enjoy in anticipation as well. Of course, if your plans are too easy and there is no risk that you will fail, then it's also kind of boring. And I kind of like to do stuff that is not easily done with standard software. I like to program stuff, so that's kind of where I look for interesting projects. And of course, the end result is also nice, but it's not the main thing why I'm doing it for. So I like to think that these shapes that they dug up are the way they are because, of course, they didn't have LEDs when they made them. So for me, the project usually starts with some interesting mathematical idea. So I wanted to make a spherical display, and then you kind of, to approximate this, you can use a polyhedra. So these, the platonic solids are kind of the most well-known polyhedra, but they're a bit boring. So when you search on Wikipedia, you find different types of polyhedra. So these are the Archimedean solids. There are 13 of them. The most well-known one is the buckyball or the football. But there are also other interesting ones. So they're characterized by the fact that they have regular polygons as faces, but there can be many different polygons. But the vertices, so the points on the polyhedron, are always the same. So you can rotate or rotate the sphere and overlay one point over the other, and then you get the same shape again. But there's another group of solids called the Catalan solids. There are also 13 of them, and that's not a coincidence, where the faces are all the same, and the vertices are different. And the fun thing is that you can create a Catalan solid from an Archimedean solid by taking all the points and then laying a flat plane across them, and then use those to create the faces. And because it's symmetrical, all the all the planes that are created are also symmetrical. So yeah, and then this is called a dual of an Archimedean solid. The thing that could catch your eye is that the faces are all identical, which is nice for if you want to make them out of PCBs. So that's one of the reasons why I initially chose a Catalan solid. So this is the shape I chose. It's kind of nice. It's sort of it looks interesting, not too complex, but it looks still a bit mysterious. Kind of a shape the Borg would use for a spaceship. So then the first puzzle, of course, is to calculate calculate the shapes that you and the shape of the PCB that you need to order. For Catalan solid, like I said, it can be generated from its counterpart, Archimedean solid, and you can find the definitions for those on Wikipedia, so that's kind of nice. And then for being able to piece them together, it's nice to add notches, so you can just combine them easily. When you've done this, it's always nice to check it. So I always program a script so that they generate either SVG or OpenSCAD, and then you can use the SVG to either laser cut it or order PCBs, and use OpenSCAD to verify that your math is correct. Of course, then you design a PCB. For this, you want to kind of position the LEDs in a nice way. And then you decide on how to wire the PCB, which is important if you need to create connections. Sometimes for a different shape, like this one, I create a wiring diagram in OpenSCAD if I have to wire it myself, which is a good idea if it becomes complex. And other times you're wiring, so these are LED strips, so sometimes wiring gets a bit difficult. So for one type of sphere I made, I calculated all possible routes that LED strips could take through the mesh of the sphere. So you decided on the shape, you've ordered PCBs, and then the fun, if you like soldering, the fun part starts, but maybe not so much, because when you do the calculations, every minute you spend on one of these facets, if you have 60 of them, takes you 1 hour. So you start on one facet, you time it, it's an hour, so so it will take me 60 hours to solder it. Of course, it becomes easier, but still count on 40 hours of populating your PCBs. And then you think you're done. No, you also have to connect them. So that's another 20 hours or so. But then you have a connected sphere, and then from the earlier calculations, it's easy to calculate the exact 3D precisions of all LEDs, and also you can also use the orientation of your LED to make it even more interesting. So you can do light calculation. So for example here, if there's a virtual light source, and then you so the software calculates what would be the light fall of this virtual light source on the sphere, and you can get really nice effects for this. It's kind of nice to incorporate the geometry of your object in your animations. So then it's complete, but then you discover there's still a problem. You have to program it. And, well, there's a problem with the light. So LED drivers are usually 24 bits, which means 8 bits per color component. But your LEDs are usually very bright, so you want to reduce the brightness. So it becomes 6 bits of brightness, and then because your eyes don't register the light in a linear way, you kind of want to have a curve that ramps up. So you have more values on the low side, and in the end you discover that your animations, for example here, if your animation says the color brightness is between 0 and 57, then the computer will, the software will map it to off, which is not really what you want. So there are ways around this. One of them is temporal dithering, which was popularized by Scanlime with the Fate Candy board. Sadly, it's not really available anymore. But the idea is you send lots of frames at a very high frame rate, and then you send different frames every time, and then you pick a value between 2 of your 8 bits. So if you want to display a value between 2 8-bit values, you just alternate, and then the ratio between the 2 values gives you a huge way of gives you a huge gradient of different colors in between the colors that your driver supports. So because the Fate Candy only supports USB, and it didn't really fit in my sphere, and I kind of wanted to address more than the 8 strips that the board supported. I decided to write my own software for it. The nice thing is, so I like to also set myself, make it a bit difficult for myself. So I decided, what's the smallest microcontroller that can do what I want to do? So I decided on an STM32, Cortex M0, and then I just, it became an interesting puzzle for me again. So, in my system, I usually use an ESP32 for the animations, and then the ESP32 sends 16 bits values to the driver, and that one, and the STM32 will do temporal dithering. Sometimes there are other interesting challenges to be found. So the sphere I made a sphere earlier, which had which consisted of 4 LED strips, and then the strips were routed around the sphere. The problem is that means that all the edges are directional, so you can solder them the wrong way around, and on all the points, the vertices, you would have a PCB, a routing PCB, and you can pick the wrong one. So there are 90 ways to do it wrong. So I thought, well, maybe I can fix it in software. So enter the cheap 3-cent microcontroller made by Padok. So I decided to put one on every vertex. So the idea is, I built up a circuit of LED strips at every frame, so that you don't have to worry about the routing during soldering. So how it works is the chip will listen on 4 I/O pins, and then one chip will listen on 4 I/O pins, and then when the controller or another relay chip sends data, the LEDs belonging to this data line will be programmed to display a certain color. And then at the same time, the chip will listen in and see, okay, there's data coming from this line, so my outputs are now clockwise 0, 1, and 2. And then the controller and the relay chips will sometimes skip one pulse. And the LEDs don't care about this, but the controller knows, hey, this is a message from me. It will read a 7-bit packet. So 3 bits for which output to turn on, and a 4-bit counter to say the next 4 bits will, say the next 3 messages will not be for you. You should relay them and ignore them. So this way you can get quite a funny, easy to use ball, easy to solder ball. So I kind of like that kind of challenge. A third kind of puzzle are the construction puzzles. So a friend asked me, you made a big ball, how small can you make them? So I thought a bit about this, and it was, at the time, still a bit hard to order flex PCBs, and I thought that didn't really meet my needs. So I thought that if you try to mill a PCB and then try to bend it. So I ordered some PCBs and then CNC to mill it. As you can see, failure is always an option. The yield was kind of really bad, but the ones that survived were kind of really nice. So I basically milled most of the circuit board away, and then so that the circuit board could be easily bent. So the result is kind of a nice, tiny sphere. Other than that, I also kind of enjoy making little jigs. So this one is meant for the sphere that I showed earlier. And if you make a jig out of a PCB, you can make soldering a lot easier and make it, make it very precise. Furthermore, I like to, I also enjoy making testers. Partially because it's not so nice if you solder a ball and then it fails, but mostly because it's nice to build testers. It's another challenge, and I think the end result is, it's not so much the end result for me, but more the challenge. So yeah, I also advise you to build them. So thanks. Are there any questions?
So how is it with the software that drives those light patterns? Is it all self-contained in the sculpture, or do you also have some where you have a computer outside and where you can, I don't know, display different things on them?
I started out with Raspberry Pi externally, but so nowadays I usually use an ESP32 internal because it's nice. It doesn't need a lot of setup, and it's fast enough. So.
Hi. I was wondering, you have this STM chip that was doing the sort of flipping between the two light levels, is that taking in just like the normal signal that the LED strips would take and then converting it kind of internally, or is there some external representation you have that you do conversion on?
So the ESP or another, the source of the animations delivers 16 bits per color component data. And then you take the highest byte and send this out. And then you take the lowest part and then, remember it. The next time you add with the remainder, you add the lowest part of again. And then if there's overflow to the high byte, you send out one extra. And there's so what I do is I don't allow for very low values in the lowest part, because if it's, for example, a 1, then only 1 in 265 frames you will get a 1, and then you get this 1 hertz or a flickering, and that's not nice. So I have a cutoff if it's less than 16 or 12, depending on the frame rate that the microcontroller can do. Just make it 0 or make it 1, make it a bit more. So that's kind of how I approach that. Another one question.
Just wanted to ask, how do you do cable routing in OpenSCAD? Any libraries? Is it your own? Yeah, this.
Yeah, for OpenSCAD, for cable routing, I just hope for the best. So.
Thanks very much. We'll be setting up for the next talk. And yeah, I think we got to take the sphere. So give us a few minutes and then we'll get ready.